Hello everyone, welcome to this video. Last year we published a conference paper titled The Effect of Substrate Temperature on Aluminium Thin Film Prepared via Magnetron Sputtering. As you can see, it is published in the Materials Today Proceedings Volume 5. I would like to present to you the presentation I made towards that conference in 2018. So the conference was in India, Hyderabad, 17th of March 2018. So here I'll present to you the mode of presentation, and then next I will give you a background of the applications of aluminium thin films. One of the things is aluminium thin film is used in coating of steels, which are widely used in various applications. And one of the problems with these steels is they experience a lot of corrosion. So there is need to coat, and mild steel are coated with aluminium films. And one of the ways is to prepare these films through magnetron sputtering. Magnetron sputtering has been shown to produce films with less defects, and the quality of the film is said to depend on various processing parameters, which include the power, the system pressure, temperature, voltage, substrate quality, composition of the target, the temperature of the target, the voltages, and so forth and so forth and so forth. So in this case, we present results of our preliminary work on preparing aluminium films on mild steel substrate. We present the effect of substrate temperature, and we evaluate the topography and the microstructure of the films. So in the methodology, the substrate is basically mild steel, one of the highly corrosive, and the target, as indicated, is the pure aluminium of 99.99%. So the target was kept at varying temperatures of 60, 40, 60, 80 and 100 degrees. We used a constant time of 2 hours, argon flow rate of 11 standard square cubic meters, base pressure of that, working pressure of 200 watts, and the characterizations undertaken were SEM to show the surface microstructure, AFM, and XRD to do the crystallinity. As for the results, these were the SEM results, and the microstructure consisted of layered surface structures with terraces between adjacent structures, coherent arrangement of the structures with clear terraces were observed at 40 degrees, which means by increasing the temperatures, the terraces tend to disappear. These are the terraces I'm talking about. They appear as elongated trenches along the structure, but the cracks start to form at higher temperatures. The AFM results show that the root mean square increases with temperature, and a plot of that is illustrated. And the higher temperature can be associated with aggregation of at higher temperature there is aggregation of structures and hence higher surface roughness. Then we did the section profiling, and the structures were shown to exhibit periodic structure, and the lateral sizes shown to increase with temperature. As such, we did a power spectral density of the images, and we used two-dimensional fast Fourier transform algorithm. These are the power spectra of the images, with the dark region showing the low frequency region, and with the brighter region showing the low frequency region, and the darker region showing the high frequency region. The PSD profiles were computed, and the correlation model fitted as shown. And this is the key correlation model. That it can be seen that the PSD decreased with temperature. As the highest is at 40 degrees, the highest is 40 degrees, and the lowest is at 100 degrees. So the value of B, which measures the spectral length, decreased with temperature in homogeneous lateral roughness, which means there is an homogeneous lateral roughness at higher temperature. The next was the XRD. There is not much about the XRD information in terms of the temperatures, but you can see a bit of crystallinity of the films. The structure at both 80 and 100 degrees are nearly the same, so there is not much change in crystallinity between 80 and 100 degrees. We can therefore conclude that temperature affects the quality of the aluminium films. More analysis at high resolution of microscopy canonical characterization is ongoing. It is reported in future papers. So these are the references, and thank you very much. If you read our full paper as it is in the Science Direct, you get to understand how the PSD, especially the correlation length, relates very well with the distribution of these the surface structures and the relationship with the microstructure. So thank you very much. If you have question, please you can contact me via my email or through the YouTube channel. Thank you very much, and like my channel. Goodbye.